arbitrary the points that I picked to give you a quiz, yes? What really sucks, and this has happened to me, I'm like, we took a quiz, 2 days later, I'm like, I totally get it now, right? So that's why I let you make corrections. This is why I let your grade be more dynamic than static, because it should mimic how you understand things. That's what I'm trying to do anyway. Okay. It's dope. Okay. I try not to let, grades mog you. Did I use that correctly? Is that?
You're getting it, Jeff. You're getting it.
Okay. I don't think people that even use the word mog completely know what it means.
No,
they
I
just
know.
kind of get a vibe from it. Is that how it works?
Huh?
Does it have a definition or does it have a vibe?
It's like, well, I use it as like a vibe kind of thing, but like the definition is like, you like look better than someone else. Like if me and Kendall took a picture and I look better in the picture, I mocked Kendall.
All right. I'll let you guys know this. While I'm grading papers, I'll sometimes listen. There's a dude named Dean Withers.
Ooh.
He's a political commentator. He's a young dude. He's like 20. And every now and again, somebody will come up. He does like phone debates. Somebody come up and say, "Cookie King mobs you. Cookie King mobs you." That's the first time I ever heard. Does that name make sense to you?
Yeah,
I don't have a clue who the shit that is. But that's the first time I heard the word mog.
Yeah, it's like.
And then I looked it up and it's like, we're not sure what it means.
There's some guy on TikTok.
Yeah.
But like for me, I say
Yes.
I mocked this guy.
Please it us. Change the subject.
What's the remainder here?
Say again?
Remainder here.
Oh, so that is really quickly here. Because it's really nifty. I kind of explained it once, but I didn't really go too deep into it. Did you bring any paper, Jeff? You did. Where'd you? There it is. Really quick. Let me just make a simple little dude here. Can you guys? I'm going to do this kind of quick. I think we're all pretty good with synthetic division. So if I synthetically divide by 1, bring the 1 times 1, add, multiply, add. Okay. Now, watch this. If I look at this as my function, Jeff, that's the one that's dying, I think. Poor little guy. Okay. Did I bring? Yes. Okay. I have colors and stuff. Okay. If I look at this as my function, can somebody help me out figure out? So f of x is this, yes? What is f of 1?
1 squared minus 4 times 1 plus 7.
And what's 1 minus 4?
3.
Plus 7?
Okay.
So the remainder theorem says, if you synthetically divide by a number, whatever the remainder is what you get when you plug that number in. That's kind of nifty. Because sometimes it'll be quicker to synthetically divide than it will be to plug a number in. Now that was easy. Plugging 1 in was easy. I don't know if you guys are with me or not. Yes?
If it was divided by x plus 1, would you plug in -1?
Yeah, so here's how you fully use this, you ready? So somebody gives me a polynomial. And then they'll use the remainder theorem to figure out this. What I do is I synthetically divide by 3. And then whatever I get at the end is what I would get if I plug a 3 in.
Yeah, I get that part.
Okay.
The remainder theorem in the textbook states that it's x minus k, f of k so is it, if it's
So in this case, it would be related to divided by x minus 3. So if I divided by -1, that would be related to x plus 1. Yes.
so you would plug
That woke you up. You all right back there? Did the chair just go crazy?
Yeah.
All right.
you would plug -1 into the function if it were being divided by x plus 1.
Of course. Yes.
That's it.
So real quick, just go with it. Let me show you the whole picture here, okay? Do you guys remember, so this thing I just did, what did I actually just divide by? What did I divide p of x by?
X minus 3.
X minus 3, yes? So we just figured out that if I do that, what would I get? What is this?
X squared
Yeah, x squared?
minus x plus 2 plus 12 minus x minus 3.
Okay. right? You guys with me? Now watch, this is so cool, okay. So we've seen that before. That's the technical definition. That's what's really happening. It looks gross because it didn't go in evenly. When it goes in evenly, it looks beautiful because it factors perfectly. If it doesn't go in evenly, we got this freaky little remainder dude. It's not his fault, you're okay. If I multiply both sides by x minus 3, and this is kind of like, I've done this before with you guys. I might not have said it exactly like that, but. What is x, so x minus 3 times this is here, is that cool? What do I get when I multiply this by x minus 3? What happens? Now, real quick, if I plug a 3 in, this is a way to, not factor. Why is this not factored? Why is this not a factored form? It's got a freaking plus in it, right? If I said factor 18 and someone said 15 plus 3, I'm like, what the shit's wrong with you? Factorization means it's got to be a multiplication. But do you see how it's sort of partially factored? Yes? Mm-hmm. If you plug a 3 in, and again, does everybody really understand that this mathematically is the same thing as that? These are mathematically the same. So if I plug a 3 into this, what is this? So what's this whole piece? So what do I get if I plug a 3 into P? I get freaking 12, because the rest of it goes to 0. Mm-hmm. That is the full story of the remainder theorem. Okay, I like it, I like it. Why didn't I necessarily go into that full before? Because it's not really that important. It's neat. It kind of, if it doesn't work, it at least tells you something. Yes? Okay, I like it, I like it. All right. Anything left over from homework or other things from the quiz or anything that you want to do before we get back into where we left off? Does everyone have this? Do you have it, Jeff? Yes. Does everyone have this worksheet that I gave out at the end of class? Mm-hmm. Does anyone need this worksheet? I know some of you do. So at this moment, I'm like, who's not paying attention to me? Okay.
Oh, I think it's this guy right here.
You one, right? Oh.
Yeah, thank you, sir.
You got one, right, kid?
Yes.
Okay. You got one, Maria, right? In case you want one, yeah. I sort of do, except it's the one that I'm going to use. Who needs one?
I think I have an
Okay. So here's what I want to happen today. I want to do these two on this worksheet with you, and then I've got a worksheet for you guys to do that's going to also include something that leads into the next section. That's my plan, just to let you in on things. So I'm going to kind of get your help on how to do various parts of this. If you were not here yesterday, maybe this is a good idea. Before we do this sheet, this will be a good primer if you weren't here and a reminder if you were. If I give you a rational function, I don't know what it is with 4 and 7, but apparently I like them a lot. The horizontal asymptote. What that means is what the function is going to do in the long term, right? What the function? It's what the function does in the long term. So you guys have seen graphs that look like this maybe, yes? So this would be the horizontal asymptote. When my inputs get really big, my function's outputs have to be getting close to that.
Right.
That's the idea of an asymptote. Okay. The horizontal one is not really a wall because it will let my function go through, but my function must eventually get closer to it. In fact, it must get arbitrarily close to it as it gets larger and larger inputs. So the whole thing is about what happens to my function if I let my input get really big, positive or negative. So right now I'm just going to look at the positive. And just to remind you, this notation says, basically, this means limit, but that basically means, what are my output doing? What's my outputs doing as my inputs get really big? Okay. In this case, what's growing faster? The top or the bottom, and how do you know?
The bottom.
Why is the bottom growing faster?
Higher degree.
Higher degree. You with me? So when I put a billion in, a billion squared is pretty damn big, but a billion to the 5th power, it's like a billion squared is nothing to it. Yes? So the bottoms are like overwhelming the top. So my outputs are getting smaller and smaller and smaller, so the limit's going to be 0. So I would say my horizontal asymptote is y equals 0. So whatever this function looks like, it's going to have, at the ends, it's got to be approaching it, either from above or below. In the middle, it can do all kinds of weird wobbly shit. Yes, okay. So horizontal asymptotes are all about, when I have rational functions, they're all about where's the degree bigger. Right? If the degree was bigger on the top, then the inverse is going to happen. Now the top is growing much faster than the bottom. The bottom can't keep up. So it's trying to divide it to keep it small, but the top is just growing way too fast. So as I put more bigger and bigger inputs in, my output's going to just keep getting bigger and bigger. So that limit is not going to exist. It's going to go to infinity. We're going to talk about this situation because it leads to something called the slant asymptote. I sort of got into it last time. We did a Desmos graph, and I'll show you another one. I'll remind you about what a slant asymptote is. They're not quite as important as general horizontal asymptotes, so I'm not going to make a big deal out of them. But they do bring in a practical application of long division, right? Which is kind of nice. If we have to do this long division as a student, you're like, what the shit do I care about this? Well, here's one reason. So this would mean the limit is actually infinity in this case. So bottom power higher, the outputs go to 0 because the bottom is getting bigger than the top. Top power higher, the whole thing goes to infinity or negative infinity, depends on what the output you're doing. So the only situation we haven't looked at is what if the powers are the same? Do you guys remember what happens in this situation if you were here? Yeah, the long way to do it would be dividing by... No, you're fine. No, great. Sorry, I didn't mean to say it like that. The way we started, and Braden's remembering perfectly, I divided by the largest power. And the reason you do that, if I divide by the largest power, and why am I allowed to do that? The only number I'm not allowed to divide by is what? 0. And what's the whole idea of horizontal asymptotes? Let x get really big. So I'm nowhere near 0, so I'm allowed to do this. So if I do that, I'm going to get 1 plus 5 over x squared minus 11 over x to the 4th, right? 2 x's cancel here. No x's cancel there. Over 2 minus 7 over x plus 2 over x to the 4th. So here 3 x's cancel, so there's 1 left on the bottom. Here nothing cancels, he's got all of them down there. Each one of these, as x gets really big, goes to 0. So then the answer is 1/2. So if, and I love this idea, if the top and the bottom are growing at the same rate, they're each keeping each other in check. The bottom's not letting the top go to infinity, the top's not letting the bottom take it to 0. They're going to agree on some finite number. And what's that finite number? The ratio of the leading coefficients. That kicks so much ass. So when you get to calculus, you're going to be doing these limits. The way I teach it is, I say we learned this in pre-calc, quick review, less work to do, because we've already done the work. So I don't know who you're going to take. I'll take with you, but you can remind them, hey, that's some shit I did in 171, man. I know how to do that crap. We'll see what they say. Okay. The other side of the coin is the bottom. So we got horizontal asymptotes come from letting x get really big. They are related to end behavior. What happens at the ends? Because at the ends is where x is really big, positive or negative. Vertical asymptotes, where do they come from? Well, when a mama asymptote means it. No. Where's the vertical asymptotes from? Not the x-intercepts.
Values of the domain can't handle.
Yes, they come from domain issues. If there is an input that makes my function freak out, I'm not going to let my function go there. I'm going to either set up a wall or I'm going to put a hole there so my function can't go there because it'll freak out. So for example, very simple example. If I have this, what value of x would freak this function out? 1. Yes? The only thing that would freak this kind of function out is at the bottom of 0. A value of 1 makes it go to 0 on the bottom. About right. What the shit that
It's just like alright with a B. Alright.
Oh, thank God that was developed. That's what the world was missing.
But then there's also alright.
Alright, we're gonna leave that alone. So the vertical asymptote in this is 1. So if we go to graph this thing, at 1, what am I gonna put there? Well, I'm gonna put an x equal to 1. Huh? Not a circle. So what would make me put an open circle somewhere?
Oh, if they cancel.
If there was an x minus 1 on the top and they cancel. Yes? So we'll do an example like that in a minute. That didn't happen. That x minus 1 doesn't get canceled. It's able to freak the whole thing out. Yes? Do you guys agree that the going to infinity is much weirder than just sort of like having a little hole there? It makes the function look a lot weirder. Yes? Well, yeah. If there's no way to kill this dude, he's able to freak it out when I get close to 1. So it freaks out. Yes? If there was an x minus 1 on the top, that would kill that freak out. It wouldn't make it look weird, but we still have to put a hole there. Because what's the one time that x minus 1 divided by x minus 1 is not 1? There is one time when x minus 1 divided by x minus 1 is not 1. When x is 1. Because 0 divided by 0 is not 1. 0 divided by 0 is somehow every number in existence.
What?
Go with me for a second. What's 6 divided by 2? I think I did this before. We'll do it again. 6 divided by 2 is 3. Can you explain why using multiplication? 6 divided by 2 is 3 because
2 groups of 3.
3 groups of 2 is 6, or just 2 times 3 is 6. Right? You guys with me? 6 divided by 2 is the number that it takes 2 of to become 6. 0 divided by 0 is the number it takes 0 of to become 0. Or if I say it a different way, 0 divided by 0 is the number that when I multiply by 0, I get 0. What number doesn't do that? Stay with me. What number doesn't do that? Let me write it down.
We all do it.
What number do I get 6 when I multiply by 2? There's only one number defined to do that, yes?
Yeah.
And just to remind you, what number do I multiply 0 by to get 6? No. There is no number defined to do that, so we call that undefined, yes? Now, 0 divided by 0 is the number that when I multiply it by 0, I get 0. Is there any specific number I must use
No.
for that to be true? I could use any freaking number I want to. The same way 6 divided by 2 is 3 is the same way that 0 divided by 0 is every number in existence.
That's insane.
I know.
I like that.
Thank you. So, the one saving grace of this situation, let me get a little hummus. If the problem had actually been this, do you all agree with me when I try to plug a 1, I get 0 over 0?
Yeah.
The one saving grace is, if you do get 0 over 0 for a number, what that means a lot of the time is you can cancel the thing that's making that happen. So then this freaky ass shit just becomes 2x everywhere except what? It's going to be the line 2x. Except at
1, 0.
1. 1, 2.
Wait, what?
If you plug a 1 into 2x, what do you get?
Oh.
So that's where I put the circle. You with me? So either there's going to be a wall, because that's like the function protecting itself in that weird thing, or there's a hole, because it's still weird, but at least the weird is canceled. But it's still like, don't go there. It's just, that's where weird shit happens. I don't know if you guys are with me.
I like the black one. Sorry.
Oh, well, I mean, dividing by 0 is called the singularity sometimes, and I get confused. Let's not go there. Let's not go to
Let's not go to 6.
quantum mechanics near a black hole. Let's not do it. Alright, so coming back to this guy. Got off track there. At 1, in this case, the freakiness didn't cancel. We must establish a wall, yes? And then I can investigate, like, can somebody tell me, for example, x equals 1 is our vertical asymptote. What situation am I in for the horizontal asymptote, now that I talked about it a minute ago?
The degrees are the same.
Degrees are the same. So what is the horizontal asymptote? Yeah, what are the leading coefficients for the top and the bottom? Well, the top is easy. Yeah, and the bottom is 1. So 2 to 1 is 2. When the degrees are the same, the horizontal asymptote will just be the ratio of the leading coefficients. That's it. So there's going to be a wall this way, and that wall is going to be one I can actually get through. Okay. So at 2, there will be a wall this way. How are we doing? Last time we really focused on the vertical walls, and I kind of talked about the horizontal walls. Can somebody tell me what the x-intercept is? Or the y-intercept, either one. Let's do the y-intercept, guys. That's easy. What's the y-intercept? How do I always find the y-intercept? To make x0. What do you get when you make x0? 2 times 0 is? 0 divided by, who cares? 2 minus 1 is 1. So 0 divided by 1 is? 0. So that is also the x-intercept, right? In fact, there's only one x-intercept. Okay. We'll stop for a minute. Can somebody tell me how many regions did we just chop this into?
4.
I like the 4. The 4 is a good, I like this idea, but 2 main ones. Here, here. Now, think about it in 4 though. So there's got to be something here, and there's got to be something here. It could either be up here or down here. How do you know? Is everybody with me what I just said? What does my function have to do? It's got to approach this, and it's got to approach that. So it could do it up here, or it could do it down there. How do I know it's not here? What would have to exist for it to be here? There'd have to be a way for it to get through here. Yes? And the only way you could do that is if there was a x-intercept. So I know it's up here. Yes?
So why is it not 4 sections? You said it was 2 sections? Is it split both ways?
There's 2 regions I must get an answer in.
Okay.
I need, and then within each region, it could either be here or here. It could either be here or
4
here.
possibilities, but
Yeah.
there's 2 sections.
There's 2 regions you need to draw stuff in. Within those 2 regions, it could either be here you're going to draw, there you're going to draw, here you're going to draw, there you're going to. Okay. All right, so there's nothing wrong with looking at it as 4, but I don't want somebody to do this and then this because that's not even a function. You know what I mean? So it's 2 main ones, and then within there it could either be up or down. Okay. You guys kind of with me? So if all I wanted was a rough sketch, you could just do this shit. If I wanted something more precise, you could plug 2 in and get what the output is. And then you know better where this was. Over here, it could either be up here or down there. And for 2 reasons, it's not up here. One, there is no y-intercept up here, it's down there. And the y-intercept's down there, so it's got to be down there. I don't know if you guys are with me.
That makes sense.
Mm-hmm.
There's only so many ways this could possibly happen. We've put the walls in. Like I said last night, we constrained this thing. So once I know like one point in these certain regions, I basically know exactly what this thing is doing. So this is going to look like this. If I wanted something more precise, I could like plug in -2, yeah? You know, it's just to see how quickly it gets close. Maybe it takes a while for it to get close. Maybe it gets close really quick. But in terms of a rough sketch, this, you know, tears streaming down my face. How do you guys feel about that? Yes?
Can you explain how you got the horizontal asymptote?
Yeah, so we're in this situation, whenever I ask for horizontal asymptote for rational functions, ratios of polynomials, where's the degree high?
It's
but the degrees in this case are the same. If they're the same, it's always going to be y equals the ratio of the leading coefficients. So y equals 2. Okay. So I'm just going to put that little, I wouldn't call it a wall, I call it a suggestion, right? Did we, in this case, does it look like we passed through that wall? No, but again, the funkier the function gets, the more it could possibly go through that wall, that horizontal wall. Okay. How are we doing so far? So let me ask you this. You guys, most of you guys, got this last night.
Mm-hmm.
Did anybody try this yet? No. You did? Okay, thank you. Okay, let me think. So let's do this. I'm going to do this problem with you. I'm going to let you work on this problem kind of alone, and then we'll look at it together, and then I'm going to let everybody get into groups and work on something else. Another problem like this. Okay. So let me ask you this. What do you think a really smart thing to do, even before I start asking you questions? What's a really smart thing to do with the function I gave you?
Get rid of x squared.
Do it again?
Get rid of x squared.
How do you mean get rid of it? So can you reduce 5 over 8? Can you reduce 5 over 8? I think I know what you're saying, Kelvin. Can I reduce 5 over 8? No, hell no, even though 8 is 5 plus 3, yes? Because division cannot cancel part of addition. So I can't just cross through these. Because they're involved in subtraction and addition, yes? Okay, so I'm not sure, I think that's what you were trying to say, yeah? Alright, I don't blame you. I look at that and I'm like, please dear God, let that go away, that make everything better. But it doesn't, because division's not that powerful. Division can only cancel it if it's only multiplication and division.
Figure out the x-intercept.
Yeah, so there's a general good thing to do with the top and the bottom. Factor it. First thing I would do if I were you, if I give you a problem like this, and I'm asking this kind of questions, just factor it right off the bat. Factor the top, factor the bottom, right? What can come out of the top? 3. And the bottom you can do like this, yes?
X plus 1, x minus 1.
Yeah.
X minus 2, x plus 3.
Good. The bigger one's got to be positive, so the middle comes out positive. I like it. My paper's all curly. I write so bad, I don't need anything else making my writing worse. Let me try to rewrite this. 3 times. Okay. Can somebody tell me the intercepts? The x-intercepts, let me say. X-intercepts.
2, -3.
You gotta be careful. Where are x minus 2 and x plus 3? Where are they? They're on the bottom. If you make them 0, what will that do? If the bottom is 0, what happens? I'd be divided by 0. Can I divide by 0? No. There you go. Those are going to be what? What's the bottom going to eventually tell me? Vertical asymptotes. Where I have to put my wall so my function can go there and freak out. So where do my intercepts come from? My x-intercepts. What do I do to figure out x-intercepts always? I make y 0. What is y also called? X is the input. So how do I find my x-intercepts? I find what values of x make my output 0. How can a fraction be 0? The top is 0. So there you go. X-intercepts will always come from the top. If you can make the top 0, you found an x-intercept. So of course, what are they then? Negative 1 and 1. Kick ass. Okay. I heard some of you guys saying that earlier. I just want us all to be on the same page. Kick ass. If I ask this kind of question, am I done? Y-intercept. Good. Tell me to say that. I think you're going to say Bahrain. I'm like, not many people know the country. So how do I get the y-intercept? How do I always get the y-intercept?
X is 0.
And this kicks ass, watch. The big finger of justice here. If I make x 0, all this x stuff goes away. They all become 0, yeah? So what's the answer? 1/2. The negatives cancel, 3 over 6 is 1/2.
Yes.
Okay. So my y-intercept will be 0, 1/2.
Bro. No one's talking to you, dude. Go ahead.
Oh, never. What he said. Now, hit me with the vertical asymptotes now.
X equals 2.
X equals 2,
Negative 3.
x equals negative 3. Kick ass. So that's where I'm going to put. Those are where I'm going to put. When am I going to put it? 2 and negative 3.
The walls.
Okay. How are we all doing so far?
I'm having a great time.
This is exactly the way that I set up a problem, by the way. I'm never going to give you a problem, just say graph this, and then you have to remember
You should.
intercepts and stuff. Okay, I'll make one for you.
No.
I'm not even joking.
Oh.
Okay. This is the way I set it up. So find the intercepts by the vertical asymptotes, horizontal asymptotes, yes? So you don't have to remember all the elements, you just have to remember how to do each element, yes? So just remember vertical asymptotes are from domain issues. You're saying, don't go here. Horizontal is kind of like, hey, eventually, can you get close to me? Yes? Oh, yeah. So horizontal asymptote, what situation am I in?
The same degree.
Yeah, the same degree. So what will the horizontal asymptote be? Yeah, y equals 3. 3 to 1, yes? Okay.
Yeah.
Here's something else I'm going to do for you. I'm going to give you a couple points that will help you with where things are supposed to be.
Okay.
So what's f of negative 4? Divided by 6, which is 15 halves, which is 7 halves. I'll get there eventually.
Oh, shoot.
And then f of 3, so this is the point, negative 4 is 7.5. And then f of 3 will be 3 times 4 times 2 over 1 times 6, which is 4, it looks like. By the way, does anyone see what I'm doing here?
Yeah.
I'm using the factor form. It's actually quicker if you want to, no, if you just want to plug in an old calculator, you just do that. I got 4. I think that's right.
That's what I got.
What is the biggest output that I see? From all the, guys, from all the points, all the intercepts, all the asymptotes, what's the biggest output that we got from anything? 7.5. I've got to make sure my scale goes that far. I don't want any of this draw your own grid. You've got to make a good scale.
Right.
So what's a good scale to go by?
By 2.
By 2.
On the Y.
Yeah. 2, 4, 6, 8, 10.
And then you should make the scale be 1 on the x-axis. That's so awesome.
Okay, let's see. That should be enough. So first thing I always do is I plot the intercepts and the walls. So let's see. My intercepts are negative 1, 0, and 1, 0. My y-intercept is 0, 1 half, and the scale's a little trippy, but 1 half of 1 half.
You shouldn't be able to plot negative 4. That's not negative 4.
Do what? Sorry?
Well, because the asymptote, the vertical asymptote is x is negative 3, so if you're trying to plot x equals negative 4,
That's fine.
why?
As you get close to negative 3, you're supposed to be going to infinity. Nobody said how quickly or slowly you're going to do that.
Oh, it's coming this way.
Yeah. Is everybody cool with this so far? So I'm going to have each of these questions for you. You're going to be gathering stuff that you need to know. Plot the intercepts first. Plot the asymptotes now. So we got 1 at 2, x equal 2, and I got 1 at x equal to -3. And then I got 1 at y equals 3, which is right between 2 and 4 there. So it's okay if, so do you guys see the main regions? How many main regions do I have to worry about? 3. So I've got to figure out where it is here, where it is here, and where it is over there, right? I got two pieces of information that aren't that great. And there's one thing I didn't say on this sheet, but I did on the other sheet. Let's see if you guys will. What's the multiplicity of these roots? 1. So what are they going to do at each intercept? Go through. Do you see the y-intercept there?
Yeah.
What is the only way this could possibly work if I'm going to go through each of those intercepts and I have to hit that point there? Yeah. So I got to approach this, I got to go through there, I got to hit the y-intercept, I got to go through there, and I got to approach this. So that middle one had all the information, that little freaking jerk stole all the information. So the middle is completely determined. To be really honest, the outsides are also determined. But why did I give you the points I did?
So that we can draw it.
Yeah, so I told you to figure out what f of -4 was, because that's here.
Yep.
I have enough information here to know it's not going to be down here because there's no intercept. So I know it's going to be up here, but I just wanted to have more information. So 7.5 is right there. So it's got to come down from this asymptote over to that one. Same thing over here, right? Are there intercepts here? No, the only intercepts were in there. So I know it can't be down here. It's got to be up there. But f of 3 was 4. F of 3 is 4. So now it's going to slam up against that dude and come over that way. Come out. Trippy. So in the interest of, dear God, Jeff, shut up, I'm going to go ahead and give you this instead of doing the other side of this. I want you guys to work on this together. I've asked all the questions like I would as if it was a test. Come on. Let's see. Oh, sorry. I gave you a copy, right? Yes, I did. Okay. I gave you a copy of this. All right, let's see. Let's just do. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's do this. Work on it a little bit by yourself. So you go into a group with some idea of what's going on, and then I'll put you in groups.
What's on this one?
So, sorry.
Yes, work on the first problem. So I'm sorry, I don't have the back. Work on the side that actually has a type. Work on this problem, yes. Yeah, what's up?
Can I get a refresher for the horizontal asymptotes if the degrees aren't the same, like what happens? No.
I like questions like we answer with a point. You point at
The
it.
bottom degree is bigger than the top, and then 0. If the top is bigger than the bottom, where's that at?
That's a funky shirt there. That reminds me of, yeah. It was a Doctor Who episode that reminds me of. Doctor Who. Reminds me of Scooby-Doo, and it reminds me of Venture Brothers in a way. For some reason, I can't remember. Sorry, Kel, I'll be right.
Alright, sounds good.
The y-intercept is going to be -0. See the best.
Then I can do.
We're not even cleaning up this f of
Yeah,
x,
cool.
graph of x.
Alright, what's the only numbers in whole baby?
Oh, we're just cleaning up final.
What else multiplies before?
Oh,
You were not allowing yourself to have the same number. That's still, you can have the same number.
oh shoot, there's a space for it.
There's a space.
Where's the other camera? I need to look at.
Is that good? Okay.
The office camera. Oh my god. The show, The Office.
Oh yeah, we're just gonna do it this way.
Okay, great job, guys.
Wow, that's not,
Yes, it is.
you know what's much
The answer could be easier.
No, that's not right.
What do you mean?
There's 2x, bro.
It's right, guy. Squared right zero.
Oh, yo, yo, All right.
All good, bro. Say, bro, I just.
Are you supposed to get a fraction
Yeah.
for the minor stuff? I got 4 over, negative 4 over 9. I don't know.
All right.
Oh, well, the line or set?
Now I'm done. Now I'm done.
No.
For the
You
x
make-
that put 0 in to get.
Oh yeah, but if you do it in this form, that's why I asked you first.
Are you tweaking?
That's why I say do this second.
What are
If you
you?
make all the
Well, I
x's
did-
0, what do you get?
We just did the 8 over negative 9.
Negative 8, no, it's not,
Oh,
I'm not sure.
I don't know either. Interesting.
It's because you left that 2 out. 2 times negative 2 times 2 is negative 8.
Oh, I see.
Yeah. But you can just from the beginning.
Every time that'll
Yeah,
work.
before you factored it, if I make x 0, don't all of these just become 0? So you can literally just cover
Did I
them.
factor that right though? That's from
Yeah,
when I
totally.
factored- Okay.
You just left the 2 out.
On here?
If you make these, no, from when you did the work. If you make
Oh,
this 0,
I
it's
see.
2 times negative 2, negative 4 times 2 is negative 8. Over.
Gotcha.
You barely put the 2 out front.
Oh, why is that a minus? That's the problem. You need them to add it before.
Oh.
Yeah, you were stuck in like difference of square
Yeah,
mode,
yeah.
yeah. Okay.
Okay.
Line shift is always the same. To find a line shift, you make x 0. You make x 0. That's why I asked this first. Before you do anything, just make x 0. That's the stuff like that. If you make x 0. Yeah, so make it equals. Yes.
Two other points. At most. That's how good logic is. But why math green?
Oh, how to do this one.
So negative 2.
Gosh, don't do something.
Oh, go back.
Oh, it's just the 2. Or
Just
the
negative 2,
yeah,
yeah.
yeah, okay.
And it happened how many times?
Okay, I should have done.
Twice?
That's the multiplicity.
I should have had one big.
Multiplicity really, literally just means how many times.
Yeah.
So if you put those together, x plus 2 squared.
Mm-hmm.
So multiplicity is power. But what it really means is just how many times
So
did
you're
it
just
happen.
saying you'll turn at that point?
Yeah,
is that
because
what
it's
I'm
of
saying?
even multiplicity. Now you know what it's going to do there. It's going to turn you.
Okay.
Good.
No, she's just angry. Chill.
Yeah, really.
Tell her to eat some food.
Cause I was like, oh no. She said, I'm gonna go, oh no.
Oh no.
Well, that's it. At most two, why can't you tell me what other points to do? Why are you making me do that?
So the multiplicity is 2. And then after root is going to do like that square. That's why even multiplicity means 2 times. So that's right. Odd multiplicity is going to be like a plus cubic.
Minus 40.
Plus 8. Where are you at right now?
Ahead of you.
What you got for?
Ahead of you.
Good. Good.
You're on the right track.
That's what I was gonna do.
Next intersection, you can just. No, the bottom is if there's 0, it'll creep the whole thing up. If the top's 0, it makes it 0.
We'll all get those numbers. So the top,
No.
the top is 18. The top is 18.
Why would 2 make it?
And the bottom is
Yeah, it's just that one, but how many times did that one happen?
16.
Yeah,
Number
that's
16.
multiplicity.
Divided by 2.
So
Get
it's
9
either
over
multiplicity or
over 8.
right.
Over 8.
Yeah, multiplicity 2, because that's showed up twice. And so what's going to do is add 5 down to true. Yeah. Oh, vertical asymptotes are what's not in the x not.
Why would he give me that?
Yeah. There's 4. So x.
You got negative
X.
9, right?
Those are going to be the vertical asymptotes.
Negative?
So at 3 negative 3 are the walls.
Yeah.
Horizontal asymptote is the
Well,
slightly
negative
freer one, but if we have the same degree, well, it's gonna be the ratio of 2 of them. Why those 2? With the horizontal asymptote. So it's gonna be, just at 2, you're gonna put a little dotted line. So, let's do this. I know you're not done, which is fine, because I wanna put you in groups. Can I get, let's see. Kelvin, why don't you come up here and work with Corinne and Mal? So you guys, Corinne, Mal?
Yeah.
Kelvin's gonna come up, you guys are gonna work together. Aubrey, can you work with Palma and Brave? Brave, you gonna work with Aubrey?
Oh, wait, this is negative 9.
Palma. So maybe you guys can go here. Let's see who else I got. Kendall, work with Alasia and Danica. Yes, Danica? You're gonna work with Alasia and Kendall. Take a plane somewhere. Find your lane. Who do I let? Oh, Sierra? Manas.
And me.
And Melissa when you're free. Manas, come over here. And then you guys are working. Did I get to everybody? I think so. Oh, damn. You're a we'll pack of 1.
I'm
No.
always last.
You work with no, you're working with we are working with us and she's here.
I'm always left last.
So help each other out, share notes, see if you guys got the same answers. Try to get through to graphing it.
Why would you give me an ugly plan?
What?
Unless I'm wrong.
Why?
No, for everyone. How'd you get 9 right?
-5. It's 18 over. Yeah, it's not too bad.
Oh, yeah.
Right over 1. It's easy to graph.
It's negative
I just need 2 other things. I want to go like
I got 8.
Square is 50.
I got 6 points.
There's negative 5, plus 2,
Oh, this should be negative.
yeah. This is answering Wait.
I got scared. I was like, oh no.
Why you said negative
Yeah.
You have to.
I put in another one as 4.
Maple was born on Sunday.
Yeah, well, first when it's something else.
Let's see, Melissa. Hey, you guys, help integrate Melissa. Yeah. We have the whole team working on it. There we go. Sweet.
I just got one. I just got negative. This is the same one talking about
Oh,
Now just jump in there.
here, I'll say it here.
Oh, there you go. Okay.
Negative 2 for the VA. Okay, negative 3 and 3.
Try to make sure everybody in your group is up on how things are working.
And then for DJ got 2. I didn't like exact after.
So the vertical is at the bottom.
I got it based off the vertical ones, based off the bottom, yeah, the diameter, and then the horizontal I did based off.
But some of those things are really little.
Horizontal is the same degree. It's just whatever.
Well, not jealous. It's because of the sun. I feel that.
It's Wednesday and I believe it's the 6th or 6th week, 7th?
Based the first one.
Daily six times.
You're asking about the horizontal or the vertical?
Yeah.
Put it on. No, we voted to allow the legislature to do it, and they haven't done it.
What's the government shutdown right
I can definitely tell you what.
I try not to bring up politics, because if anybody feels a certain way, I'll have to go somewhere and cry.
Apparently, it happens every 6 or 7
The
years.
last one was 2019.
I haven't lived in America that long,
What's
so
the
I don't know.
Nothing really changes. Unless you like work for the government, nothing really
I
changes.
googled it and apparently like lots of people research on it.
Personally, I think it's always funny when the party in power is complaining that the other party is doing it. But, you know, that's just me.
The other ones you said like more points than what it was. Like the other ones, okay.
Yes.
Oh, and it's gonna bounce it, yeah.
I don't know if it's fractions.
And I figure,
Negative 2 bounce.
Well, I show my work, so I'm not very good at this.
well,
I don't show my work, but
all of you are my favorites.
I don't show my work, but I'm always on office hours, so that,
Yes.
yeah. Don't you have things to do? And the answer is no. I know.
Okay.
Just
I'm gonna crank it up.
negative 2, 0. Is there another
Do you
one?
see how, in order for this to do this, they would have to line up.
Oh,
This can't be wrong.
so would it end there, like just end short, or is that wrong?
Bar,
So if I have a point there, how is
I
it?
needed to know whether
So,
the function was gonna be.
and amongst 2 other points, I'll give you, plug in negative 4. Figure out what the output is from
I'm
negative 4.
smart.
What do you do with this point? That's not it.
Plug in negative 4.
Oh,
For fun.
oh, wait, it's fine, but I think that's so crazy.
At least get a good number.
I know, but I'm adding, I'm adding my points. I got the.
Well, I knew that would go there.
Charged enough.
I'm just kidding, Do you work? No.
No, me not.
I
I
gotta
didn't know.
see those asymptotes. There's only so many groups I can vulture around. So if it's 0, negative, or negative 4 is 0.
Negative 4 is 0. What? No.
It's 0.
When you plug in
Cause, yeah,
negative 4,
am I tripping? Hold on, let me try it again. Negative 4.
Yeah.
I really feel like that.
negative 4 plus 2 is negative 2 squared is
Oh,
4.
never mind, it's saying wrong.
49.
That's what I like.
Yeah, which, keep going, so it's 8.
Wow. much was this semester?
That's what I was trying to remember, if it's the 6th week or the 7th week.
There's gotta be a number.
So this specific function
I'm gonna find that
has
out.
a weird thing that happens. Yeah, I didn't go into enough detail here to help them with the reading numbers. So I'm trying to figure out how to help them see what happens. What it does is it crosses. It's like a horizontal yeah, it's fine.
Oh,
I know. It's crazy. That's why I use it. Thank God.
whoa. Wait. What's happened?
These are correct. Because
Negative 4, -1. I messed up. Is that better?
-4, -1. No.
No?
He will do it. He'll do it.
Okay.
Yeah, this graph. All right, guys. Let me catch up to you. This graph does have one little weird feature.
Weird features.
Oh shit! I never did pause. That was an exciting one.
Yeah, that's from -5.
Here we got the factored form, and I think everybody got that. Y-intercept. The reason I asked for the y-intercept first is because it's easiest before you factor it. You just cover all the x stuff because they would all become 0. So you can literally just cover them up, and then you get -8 ninths. So the y-intercept is 0, -8 ninths, which you can approximate to be 0, -0.88, right? So -0.9 basically. Okay.
What?
8 divided by 9.
That's cheating, dude.
Okay, I can cheat. I don't know how I cheated, but I can. X-intercepts, now that that's factored, I only have how many X-intercepts? One, but how many times does it happen? Twice. I keep trying to use this dime pen.
Do you need a pencil?
I'll be right. I'll use this guy. Thank you, though. I appreciate that. The multiplicity of this one is 2, and you didn't have to write it like this, so if you see the power, it works, but in general, the multiplicity is just how many times the thing happened. So if you wrote this like this, -2 happened twice. So it's still 2. And that means what's it going to do at -2, 0? Okay. Or bounce. Yeah. Or
I like turns. Just for a word.
my turn looks like through. See how it looks like through?
It looks like 2, like TW.
I know. It looks like a lot. It looks like twin.
Actually,
It looks like
yeah.
torn. It looks like yeah.
Oh, no, I did.
Sorry.
You better. The vertical asymptotes are what?
-3 and 3.
X equals 3.
Yeah.
X equals -3.
Aww.
The horizontal asymptote, the situation we're in is equal degrees. So the horizontal asymptote is going to be y equals 2. Okay.
Great.
Now I asked you to figure out f of -5, and what'd you guys get for f of -5? That was the one that people were
9 over 8.
9 over 6. Positive 9 over 8? Yes. I believe.
Yes.
Okay. Now, okay. This graph has a specific thing that happens. So I did this graph for a specific reason, but it's not easy to tell from the work. Let's put what we know down here. What is the biggest output that we get? It looks to be kind of small. So it looks like we can do everything by 1s. You guys with me?
Mm-hmm.
You have to stop and think, what kind of scale do I want to use so I can actually see everything well?
I picked a 2 scale for the y-axis.
Okay.
For the right side.
You can't, it has to be the entire axis.
No. I mean because of the right side.
Oh.
Because of what it does over there.
Oh yeah, okay, let's see. And then -1, -2, -3, -4, -5. Oh, I did say at most 2 other points. Yeah. Okay. So if I did try to plot my horizontal asymptote at 2
For me, I put down 5, so.
and my vertical asymptotes at 3 and
Like I
-3,
did for 5, f of 5.
so
Like that.
let's do this. What is f of 4?
The 6 of the
f of positive 4.
72,
72 over
7.
7? Okay, that's why you did what you did.
Yes,
Okay, so this will be like, it's roughly 10
yes.
for us poor little humans. And now, real quick, okay, I want everybody kind of. This is the kind of problem I would have given us some more to do here in terms of helping you figure out what inputs you should use. Because I know I'm going to have a horizontal asymptote somewhere. I'm going to have a vertical asymptote 3, vertical asymptote -3. And so I need to know where it is here. So if I plug in a 5, I know it's going to be up here. If I plug it in, and when I get an output up there. Okay. So if this was on a test I gave you, I would have asked you to figure out what f of 5 is. To kind of help you know ahead of time what scale to do here. Because that'll, now watch. Let me just go with what I've got, because I feel like maybe somebody else did this. Did anybody else have a scale of 1 here? Or did you all have a scale of this? Okay. So here's what you can do if you did that. I'm going to put my horizontal asymptote here. I'm going to put my vertical asymptotes there. I've got my y-intercept. It was, where do you go? 0, -0.9 roughly. And then I've got my x-intercept is -2. And I know it's going to bounce there. So it's got to bounce and it's got to go through this y-intercept. So the middle region of the 3 is fully determined. You guys see how? I can't start up here and bounce because then I could never get through there. So I know I'm going to go, and I'm going to bounce, I'm going to go through there, and I'm going to go down and approach that asymptote there. Is that cool? Okay. And I want kind of, would you all agree my graph is janky? Do you guys still use the word janky? Does everybody know what the word is? Okay. Over here, I know that I'm up here and I'm up here. If you did all this work and then you plug a 5 in and you get 10 and you're like, shit, you could still kind of represent it like this. If I didn't ask you to figure out what f of 5 was, you didn't know ahead of time that the output was going to be 10. I don't know if you guys are with me. If I want to know, was it 5? No, it was 4, sorry. I plug a 4 in, I get 10. That's off my scale. Yes? It's fine to still represent that that's there. That's fine. Especially if I didn't ask you to figure out what f of 4 was. Back here, did anyone plug a -4 in? What'd you get? Oh yeah, we did it. That's one of the things. Yeah, 8 over 7. So here's what's happening that's weird back here. Are there any intercepts here? No. But you know when you plug a -5 in, you get 9/8, which is just over 1. Bless you. When you plug a -4 in, you get 8/7, which is a little bit further away from 1. Okay. So the weird thing that's happening, you guys, this is maybe a little too much. I can't possibly be doing this. Yes? And I understand if you try to force this to happen, but how do I know it can't possibly be this? There's no what here? There's no x-intercepts. This is an example of a function where it comes down, it goes through its own intercept, and then through its own asymptote, and then it kind of approaches it after that. So when x is small, it can do whatever the shit it wants to. It can cross this line as much as it wants to. So it crosses the line. When x gets bigger, it's like, oh shit, I better start approaching that line. This is an example I wanted to give you of a function that crosses its own asymptote.
I thought it can't do that. I thought it has to stay on one side.
No. So when the top and bottom were linear, then it doesn't cross through. But I keep talking about if I gave you something that's more complicated, it can go through. That's why. Oh, because. Let me show you. 2 reasons. When does a horizontal asymptote kick in? When does it kick in? How do we get it? When x gets really big. So when x is really small, I can do whatever the shit I want to. Same with end behavior. The ends have to do this maybe, but in the middle you can waddle all over, you can go all over the place. It doesn't matter. As long as you do this at the ends. Okay. Here's what's kind of cool. The horizontal asymptote is 2, yes? Okay. If I take my function and it's possible for it to equal its asymptote value, if it has an output that's equal to this. So if we solve this equation, now this is nowhere near as bad as you think. How do I solve this equation? What's the worst part about that besides it exists? It's got a denominator, so let's kill it. Right? This is not a life lesson. Don't kill the things you don't like. But in mathematics, I don't like that bottom. What can I do to kill it? Multiply by it. So I got to multiply both sides. That's a trade-off. Which actually comes out pretty nice. So these die. And over here, I'll get 2x squared minus 18, yes? Don't the 2x squares cancel? I can subtract 2x squared, yes? Yes?
Yep.
Then I can subtract 8, and I get negative 26, so x is negative 26 over 8. There is a value of x where my function output is 2. Therefore, it does cross the horizontal asymptote. The more complicated the top and the bottom get, the more it could do that. If the top and bottom are just linear, like x minus 1 over 3x plus 7, it's not going to go through. It's going to come up against it. If they're more complicated, in this case they are more complicated, they're squares, it can equal its own asymptote. And graphically that means exactly what it sounds like. It hits its own asymptote. Yes?
Where do we get that 2 from?
What was the value of the asymptote? The horizontal asymptote, 2. So I'm saying, can my function equal my asymptote value? If I ask myself, can my function hit the horizontal asymptote? Mathematically is, can my function value be the same as my asymptote value? That's the equation I would set up. Now, everything we just did here, guys, everything we just did here would be at most a bonus question on a test or something. This is a little bit beyond, but I appreciated the question and I wanted to show you the reality. So what
What if it does not equal it?
then it doesn't, it's horizontal asymptote. It actually butts up against it like a normal asymptote.
Oh,
Vertical asymptotes are what we consider when we think asymptote. They come up to it and they never touch it. Horizontal, it could go through an infinite number of times. And I showed you an example, the vibrating string that thankfully stops vibrating after a while, right? Okay. So it can go through. And the more complicated, in fact, this is just one level up. These are quadratic. I just made them squares. And I already have a situation where it hits its own asymptote. If I gave you one like this on the test or something, I would give you more information to kind of like show you that's what's happening. Because it's a little trippy when it happens. Okay. Yeah.
So like at the end of the asymptote, is it going to like be on the bottom side of
Where are we at? Sorry?
like the one that doesn't, the one that crosses, will it stay on that side?
This one?
To
This one?
the other side?
Oh, here.
Yeah, will it stay on that side when it gets closer to infinity, or will it go above?
Yeah, how many values did we get when we set it equal to its own asymptote? We got 1. Negative 26/8 is just over negative 3. And you guys see just over negative 3 is roughly where it hits, the way my janky drawing is? I need everybody with me. Elijah, you asked a beautiful question. Elijah says, this is great, math boy. It went through once. How do you know it doesn't do like you said before? How do you know it doesn't go up and go through it and just mess with us all day long? Because when I did this, I got one answer. So it only goes through once. If I did this and I got more than one answer, then it's going to go through multiple times. Does that make sense? Now the neat thing for you guys is this is actually further than a lot of instructors don't even show their like pre-calc, the 176 students this. And to me, I'm kind of happy this came up because this is a really neat thing to realize. It is able to have that output. It's able to be 2. You can see it. And that's why it hits it. But when the X gets really big, it isn't that this is a wall saying you cannot go here. It's a wall saying you must approach me. And I can approach it from one side, the other side, or both sides. If I'm doing this, as long as my amplitude gets tinier and tinier, I am getting closer to the wall. Yes? Okay. Maybe. These walls, you cannot be here. This wall, hey, can you come close to me? Hello? You're like, maybe. Teaching with voices. Okay. So the main things to know, and this is exactly the way I'm going to set it up, I think. Your job will be to answer each of these. So they're compartmentalized. You can attack each part. The people that do well with math are the people that break math problems down into parts. So I try to break it into parts for you. The hardest part, I think, is going to be getting it all together, right? Especially if you graph in your graphing calculator and you see it's different and you try to start to, I would much rather this be wrong, but it perfectly shows me what you found. I don't know if you guys understand what I'm saying. You'll get more points for that than if this is perfect and you made some mistakes. That's the way you can miss the most points. Okay, because it's important for me to grade. Can you translate what you found into a visual? Okay. I think that's enough. I wanted, on the other side of this, by the way, something we'll do first thing next time. The next thing we're about to get into is exponentials. And just a little teaser. It's always weird when I'm about to say this. We have put the variable in a lot of places. We have put the variable underneath. We put the variable with powers. We put the variable, blah, blah, blah. One place we have not put the variable yet is in the exponent itself. So these are a class of functions. You're not going to believe what we call these functions. Where's the variable? It's up in the exponent, so we call these, yeah, math people are very creative.
Wow.
Crazy.
What are you going to call this? So we're going to talk about exponential, and that's going to lead to, let me see if anybody, there's going to lead to logarithm.
An E.
And the only reason people really hate this, I think, is because we chose a word for the damn symbol. That is a symbol just like this is a symbol.
Yeah.
That is a symbol. But that throws us off because we're humans and we say that's a
Is that a three
freaking
next
word.
to it?
Yeah, it is the three.
Oh, three.
These are related to each other.
Oh, I
We'll talk
see.
about next time. We'll talk about how they're related to each other. So next time, Monday, I'll have the quizzes graded. We'll get into exponential stuff. See you guys
Gotta get
then.
it
I have a
wrong.
question. It's the homework.
Okay.
It's like, it gives me the volume, the length, and the width.